I'm talking to Bill, and he says, I want you to construct a QR policy for my 25 kilogram red bumper plates. We have our little cheat sheet here, so we know we're going to have to get enough information to do this. So we go to Bill and we say, okay, Bill, first thing we need to know is, do you have enough demand history for these bumper plates to give me the mean daily demand and the standard deviation of daily demand directly? He probably does. He's been selling these for a while. But for the hell of it, let's say that what Bill says is because, you know what, I can tell you, on a typical day, my most likely sales are 200 plates. On a bad day, maybe I only sell 100 plates. And on a good day, maybe I sell 500 plates. So he gives it to us in A, M, and B, rather than mean and standard deviation. Fair enough? Remember that for the first day, or the Saturday? Okay. So, fine. We can work with that, because now we know that on any given day, the average is equal to A, which is 100, plus 4 times M, which is 4 times 200, plus B, which is 500, divided by 6. And if y'all calculate this when we get done soon, that's 600 plus 800 is 1400 divided by 6. What is that?
2 and a third.
2 what?
2 and a third.
233.
Okay, thank you. 233. All right. 233 plates per day. Agreed? Everybody understand? We just did that equation. Now, what about the standard deviation of daily demand? It's B minus A over 6. So that's just 500 minus 100 over 6. That's 400 over 6, which is 66.7. Agreed?
Yep.
All right, so now, he might have given us that directly by just searching inside of Excel and saying, here's the mean, here's the standard deviation, or he could have estimated it and we came up with it. Now we know our daily demand. What else do we need to know? Well, we have to ask Bill, what's our lead time? And Bill's getting these, now from China is tough right now. Let's say he's getting them from Thailand, because the lower imports from Thailand, that's where a lot of the rubber's grown and stuff like that. So let's make this square root of it. He tells me that on average it's 49 days. Once I place an order before that order gets produced and shipped to me and arrives back in Apr. Okay, so we've got the mean, we've got the standard deviation, and we've got the lead time. What else do we need? Well, if we go over here and look at this, we need some cost information. So I asked Bill, how much do you get charged for each of those plates? And he goes, you know, I used to get volume discounts, but I listened to this talk by this professor, and instead I now give them a guaranteed minimum volume, and I let them charge me a setup, so now I just pay a fixed cost of $200 per plate. What is that going to allow us to do, the fact I just told that story? We're going to go to the EOQ formula directly. We're not going to have to use a spreadsheet and use SOLD or anything like that. We're going to be able to get it directly. Okay? All right. Now we got the cost. What else do we need? It looks like we need our holding rate. Okay, holding rate. So we got to talk to Bill and we got to ask him what his holding rate is. First thing I ask Bill is, what's your weighted average cost of capital? He's pretty profitable right now. He self-funds most of it, hadn't issued a lot of debt, right? Doesn't have any bonds out there on the market, so his cost of capital is pretty low. Let's say it's 6%, okay? So it has a 6% cost of capital. And the next thing I ask him is, what's the obsolescence risk of those bumper plates? I go, because you know, they do have steel in them, they do have rubber, they do have plastic. You know, do they go out of style, or do you end up losing value because the commodity price is changing? He goes, there's a little bit of a risk adjustment. Whenever I'm doing my calculations, maybe I add a 3% risk adjustment to account for the commodity price uncertainty. Whatever, I'm making this shit up, okay? Everybody okay? All right. Then we've got to cover his storage costs. That's easy enough to do. He knows what it cost him last time to run his entire warehouse. He knows what fraction of the warehouse was consumed by bumper plates. He can just apportion his warehouse cost to his bumper plates, okay? And let's say that turned out to be 1%. And And then finally I said, Bill, how much of these things do you have to write off? And he goes, have you ever seen one of these suckers? They're bright red, they weigh 55 pounds, kind of hard to steal, kind of hard to break. So we don't have much write-off on those things. Maybe that's another 1%. So basically, his overall holding rate by that simple logic is around 11%. That's very low. If he actually had that low of a holding rate, pretty good for him. Do you understand what I'm doing? I'm just walking you through the talk and the logic of what we're trying to do. All right, so now what else have we done? We got C, we got S, we got H, we got the, okay. Looks like I also need to figure out, Bill, do you happen to know how bad a stockout is for you? Can you give me a stockout rate? He goes, hell no, I have no idea. And I go, well, then I guess we're gonna have to rely on service level. And he goes, okay, what's service level? And I go, well, what likelihood do you want to run out of stock? And he goes, you know, I've been checking with my peers, and most of my colleagues are going for 90% service level. I want to be better than them, so I'd like to target a 95% service level. So we're going to go ahead and we're going to set him up with a 95% service level. And then the final thing that we need to know from him is we need to know, hey Bill, every time you place an order, how expensive is that order? Okay? How expensive is that order? And he goes, well, shoot, because I negotiated that price with them. I told them that they could charge me a setup. They're charging me $10,000 of setup every time I place an order. So we got a setup of $10,000. And I go, what about when you ship it? And he goes, well, I have to pay the customs fee in China, which is fairly cheap at about $1,000. Okay, so let's go ahead and capture that.
I thought they were coming from Thailand.
Oh, it's on Thailand, okay? The customs fee at Thailand, and it's $1,000. And then we have to have a cargo container. Anybody been doing that? It used to be $3,000, $4,000. It got all the way up to $30,000 for a container. Is it 3,000-ish now? 4, okay. So it's $4,000 for that container that we're gonna ship. Now we gotta get it to our stupid West Coast customs, okay? That's gonna be a pain in the ass, right? And they got a stranglehold on all this stuff. So they charge me $2,000 for every container. Plus, we're gonna have to deal with this tariff, okay? We're gonna have to figure out what to do about that tariff in just a minute. But let's leave that alone. And then after this, we have to ship it overland from Los Angeles to Akron. What's a full truckload now? 3,000 bucks? Full truckload? Whatever. Do you see what I'm doing? I'm just going through and trying to find out when I place an order, what are the fixed costs associated with the order. So, we've got this, we sum it up, it's 10, 11, 15, 17, it's $20,000 every time I place an order. That's just for the ordering costs. Now we've got one other thing. We gotta deal with this tariff, and I want you guys to help me. Let's suppose there is a 15% tariff on stuff from Thailand. Okay? Where are we going to put that? What does that 15% affect? Does it affect my ordering cost? No?
Portion of it. Your comp area.
It's right there, right? Isn't it allocated against the value of what I'm shipping in? It's not the cost of the shipping, it's the value. What that implies is that my real cost is actually 1.15 times my $200, or $230. 10%, yeah, that's right, $230 per plate. So that's where a tariff shows up. It shows up in the per unit cost. Okay? Turns out if we can do that, we're done. Because now, I have to give you all that. All that time we just spent talking through that, I've actually got to give you that. Once you have that, look what we do. All right, first thing, he wants a QR policy, so let's figure out a Q. How do I figure out my Q? I go, okay, I go over to my cheat sheet. Are there volume discounts? Well, if there were, I'd have to go use a spreadsheet and do this. But there's no volume discounts. What's lucky, I can just go directly to it. The optimal Q that we need is the square root of 2 times annual demand.
55,000.
Yeah, let's imagine they're open 365 days a year, right? So 365 days a year times the mean is whatever the hell it was, okay? So our mean is 233, so it's 365 days times 233 plates.
85,000.
All right, we'll do it in just a second. Okay, does everybody understand? 2 times A, 365 days times selling 233 a day on average, times the ordering cost, 20,000, divided by my per unit cost, which is the $230, multiplied by my holding rate, which is 0.11. That is all you're doing to figure out the appropriate order quantity. Yep. Okay? So if we do that, here. All right, square root of 2 times 365 times 233 times 20,000 closed divided by 230 times 0.11 closed. Did you guys get? $11,595?
Yep.
So every time we order, we're gonna order 11,595 plates. That's my Q. What's my R? Well, I have to draw that picture. So I know that my lead time demand here is gonna be a normal distribution. I need to figure out what the mean is, and I need to figure out what the standard deviation is. Remember the central limit theorem. 1, it's normal. 2, the mean is the sum of the means. And 3, the standard deviation is the square root of the sum of the variances. Okay? So I got a normal, I need to know what the mean is. The mean is the sum of the means. Don't you agree? U bar is simply, my lead time was 49 days. And on average, I think I'm gonna sell 233 plates a day. So my U bar is whatever that is. $49 times 233. 11,417. I know this one, it's 11,417. How about my standard deviation? Well, my standard deviation is the square root of, well, I have 49 days, each of them having a standard deviation of 66.7, and I have to square those. So this basically becomes the square root of 49 times 66.7 equals 7 times 66.7. You have to just take a picture because I'm making this shit up.
7.
Exam, so will I.
Real. 467. I have much more faith than you guys do. 467, okay? And this is 467. All right. If you have a normal distribution, has a mean of 11,417, and it has a standard deviation of 467, and you're looking for the reorder point, R, it gives you a 95% service level. You agree this is what you're looking for? R. This, I want a service level equals 95%. Do you agree in principle that once you have a normal distribution, you can just look it up in Excel or do whatever you want on it, right? So let's do Excel, since that's probably what you'll do on your final exam. Okay, Excel says R equals norm inverse of, I want 95%. I want mean, the mean is 11,417. And the standard deviation is 467. Plug that into R. Okay, equals norm inverse of 0.95, comma, the mean is 11,417, comma, the standard deviation is 467. It looks like R should be 12,185. Okay, so we would simply tell Bill, hey Bill, whenever you do this, I want you to order 11,595 plates. And I want your reorder point to be 12,185 plates. And we can actually figure out what our safety stock is, right? Because 12,185 is when we're going to order, but our average was 11,417. So this difference right here is our safety stock.
Average safety stock.
That's right, correct. It's average safety stock. All right. And I'm going to give you all a gift here in just a minute. We're not going to do a TTI policy. You only have to conceptually know what I talked about. We're not going to calculate it. We're only going to calculate it through all this, okay? Oh, shit, it's raining. Okay? Minus my average was 11,417. We needed 768 of average safety stock.
Which is just R minus Q.
All right, let me show you two other things, and then try your homework. We're only going to do QR policies, not a TTI policy. That's the right answer, guys, for Bill. Okay, so if we're talking with Bill, we'll say, Bill, based on the information you gave us, we need to order 11,595 plates at a time. We reorder when we get down to 12,185 plates. On average, we're going to have 716 plates of safety stock.
Instead of 716.
Yeah, the safety stock is just,
12,185.
we're going to reorder
11,417.
when we get to 12,185.
768.
But our average
Did
is
he get
only
serious?
11,417.
Oh, okay,
So
so
we're
he's
keeping the
keeping
extra.
that.
How do you get that?
Exactly.
It's your R minus
Go back to
ABS.
this.
It's
When we
716.
first started this
It should be
overall
716.
conversation, we said, how much safety stock do we need? If our uncertainty is a mean of 14,000 and some standard
12.25, which is wrong.
and we first tried, well, let's just give 10% extra. So we set R as 15,400. That's a safety stock of 1,400. And we could figure out what service level that gets us. We went the other direction this time. We said, we're going to create the curve that describes the uncertainty, and we're going to pick the R that gives us the service level we want. So what do I want you to kind of know from this, okay? So let's look at this. I want you to be able to analyze this policy. I want you, after you've done this, it'll take you 15, 30 minutes, something like that, after you try it. After you got the QR and the safety stock, I want you to be able to do this page 14 right here. So if Bill says to you, well, how much am I going to be spending on inventory on average for these bumper plates? How much am I spending? You now know the Q, the R, and the safety stock. And if you plug into that formula, you're going to find out that the total average annual inventory cost for him are equal to, now let's figure out why it's Q by 2 plus safety stock. Do you remember when we did our picture earlier, we said if you back up and look at the QR policy,
R minus U.
it kind of looks like a series of triangles. And it's a series of triangles whose height is Q.
Yeah, it's 768.
Okay, and whose bottoms, on average, come down within the safety stock. You remember that drawing? That's what we do. We looked at it long enough to be these triangles. Sometimes the bottom of the triangles get closer to 0, sometimes they're further from 0. But on average, they're whatever the average safety stock is. If you wanted to know how much you're holding in average inventory, don't you agree it's half the height of the Q, and that's sitting on top of the average safety stock? That's all that's saying. It's half the height of the Q plus the average safety stock. That's how many units you're going to have. Then you multiply it by the cost, then you multiply it by the holding rate. So in our case right here, all right, I need triangles that are of height 11,595 divided by 2. So I've got these triangles and I want half their height. They're sitting on top of, on average, 716 plates. That's the average number of plates I have in inventory. If I multiply that by my cost, which was $230 a plate, and I multiply that, that's now that's dollars in inventory, and I multiply that by my holding rate, H, which was 11%, I can now tell Bill exactly how much I think he's going to spend on average per year in his inventory if he follows my inventory policy. Yeah? So let's calculate that. All right, 11,595 divided by 2 plus 716 equals times 230 times 0.11. It looks like it's costing Bill about $164,791. $164,791.
Brett, I think your 716 should be 768.
Yes. Oh, good.
Okay, thank you.
I was like, I'm asking it.
Oh, my bad. So it's 768.
68.
Okay. Which will make that a little bit off. Did you get that number too? What's that number now?
166, 107.
Okay, thank you. All right. Suppose you go tell Bill that. All right, so you go, hey, Bill, here's the optimal inventory policy. If you follow that, you're going to have an average annual inventory cost of $166,000 tied up in those bumper plates. That's a lot of money, right? He's got probably 2,000 SKUs. So he's got a lot of money tied up in those bumper plates. What if he says he doesn't like that? Now we're getting to that question. What if Bill says, I don't want to spend that much on inventory. I want to cut that inventory cost in half. Here's where you have to start thinking. This is what the other questions are that we've kind of been talking about. If you don't like this number, what if Bill just says, screw it? A big part of this number right here is that 11,595, because that's how many you're telling me to order at a time. So I'm going to save money. I'm just going to go ahead and order 5,000 plates at a time instead of 11,000 plates at a time. What would you tell them?
That's every service level?
Yeah.
Okay, we haven't done anything with the service level yet. It's in the service level question.
R.
That's exactly right. You would say, Bill, I mean, I agree with you. You're going to have lots of little triangles now instead of fewer bigger triangles. They're only going to be height 5,000 instead of 11,595. But Bill, unfortunately, you pay $20,000 every time you place an order. The amount of money you're going to be spending on the increased number of orders is more than the amount of money you're going to be saving on the inventory that you reduce. That's the whole point of inventory, okay? It's the mistake I constantly saw all the time when I used to do this. People say, inventory is bad, I'm going to go in and I'm going to cut inventory. But inventory is there for a reason, right? If you have the right amount of inventory. If you have the wrong amount of inventory, that's fine. But if we did it right, and the numbers that we have are right, Bill can't just go arbitrarily change Q, okay? What about Or, what if you go, you know what, I'm gonna get the inventory deal a little bit lower. Instead of the 12,000, I'm gonna let it get down to 10,000. What just happened then?
Service level.
He's not gonna hit his service level. So Bill, you told me you wanted a 95% service level. So Bill, if you want a 95% service level, you can't just go arbitrarily changing that shit. That's what's needed for a 95% service level. So if you want to work, and this is actually now what you were asking a lot of, okay? This is where, now what can I change that would make these numbers better? So clearly, on your total average annual inventory cost, this is about 6,000 units on average, and this is about 768. So if you want to do something about your inventory cost, you got to do something about this number right here. This number is driven by the Q. So we got to go look and see what drove Q so high. Toyota, okay? Toyota believes, here's why Toyota ends up with very small Qs. When we were doing Q, it was 2 times A times S over C times H. Here's two fundamental beliefs of the Toyota system. You want to constantly improve your system so that setups are fast and cheap. And the other belief of the Toyota system is that inventory is a lot more expensive than you think it is. You might capture inventory with all these little numbers that Britt wrote out here, but you're forgetting the fact that what inventory does is it gives permission to fail. If you're running a process or you have a supply chain and you have big piles of inventory, what you're effectively saying is, I'm giving you permission to fail because we have a buffer against it. So what happens to this Q? The question you asked me when we were on the Toyota thing, right? I said I would get it back to Toyota, okay? What happens to this Q? If your fundamental belief is setup costs should be driven as low as possible and inventory holding rates are much higher than you think they are. That means the numerator is going to get a lot smaller because you spend a lot of time making that number small, right? And the denominator is going to get a lot higher because you think this number is not 11%, it's a lot higher. What happens to Q? It gets much, much, much smaller, right? And in the limit, that's what Toyota is doing. Toyota is not doing something different than the QR policy. Toyota simply has a belief system. Spend a lot of time and effort to get that S as low as possible, and you probably way underestimated what this H is. So we could go talk to Bill about that same thing. Hey Bill, are you sure your holding rate is accurately captured here? Maybe it's actually a lot higher than you think it is. Or Bill, maybe we need to rethink about what to do about this ordering cost because that's so high, we need to drive that lower. That's the kind of conversation you have. Does that make sense? Two last things, then we're done. That other thing down below, expected time between stockouts. This is the thing I want y'all to do. This is the one, I promise, when you sit down and you go through this, you go, okay, there's a lot of shit on the board, but actually, it's not hard once I just get it in my mind straight, okay? Here's the hard one, that service level. That service level is such a pain in the ass. Because what we figured out now, is we told Bill that the total average annual inventory cost are $166,107 or whatever. All right? Part of that's driven by a service level of 95%. How do we know 95% is a good answer? How do we know whether 95% is the right answer or not?
We don't.
You don't, because the problem is we don't know how to get this thing, right? Do you agree if I told you a stockout rate percentage is 78% and the holding rate was 11%, do you agree you could just calculate what the service level ought to be? Okay? Well here, I'm going to give you two ways to think about service level. All right? One way to think about service level. So the question we're now asking ourselves with respect to service level. Question number one is, how often is there a stockout? If we follow this policy right here, QR, like we did up here, how often am I expecting a stock count? Well, there's the equation, but it's not any different than what we just did in our mind. You remember 95% means 19 out of 20 times we're not going to have a stock out, and 1 time out of 20 times we are? Do you agree another way of saying that is a 95% service level says we are expecting 1 stock out every 20 times we order? Yes? Can't we calculate how many times we're ordering, how long it would take to order 20 times? Remember, A by Q is how many times a year we order. Q by A would be the average time between orders. So we could figure out how long it's going to take us on average to make 20 orders. That's all that goes into that equation. You don't have to follow what I just said. Just understand, that's all I did to derive that equation. So what's my average time between stock counts? Q over A times 1 minus the service level. So Q was 11,595 plates over A was 365 days times 233 per day times 1 minus the service level of 95%. Now you have to be careful because the answer you're about to get is in years. Okay? The answer you're about to get is in years. So if you're going to turn into days, you have to. So let's do this. I promise we're almost there, okay? All right, so 11,595 divided by paren 365 times 233. We're 10 minutes early. Times 1 minus 0.95 close.
Switch to stop out on this kilo,
All right, 2.73 years. All right, Bill, if you follow this policy with a 95% service level, you basically can expect to run out of stock only one order cycle every 2.73 years, 2 3/4 years. Bill, I need a gut judgment from you. Is that okay or not? If Bill says, yeah, that's about right, I'm willing to run out of stock during one of these order cycles every 2 3 years, then that service level is perfectly appropriate. If that seems like, well, maybe I can afford to run out of stock more often than that, you can reduce your service level. Conversely, if you want to run out of stock less often than that, then you're going to have to increase your service level. So this is just a gut check. That's all you're doing here. It's a gut check. You understand? I don't have an answer for you. That is your own personal gut check. Final thing. Remember this. In principle, the service level is equal to the cost of a stock out over the cost of a stock out plus the cost of holding extra safety stock. I do know this. I said this is 0.95, right? I do not know the cost of a stock out. But I do know the cost of safety stock is 11%. I can work backwards on this. I can say, what would have to be true about the cost of a stock out rate for 95% to be the right answer? See what I'm doing? I'm going the reverse direction. So let's calculate that, and then I want to clarify one thing. So if I go through and do this, right, I've got 0.95 multiplied by cost of a stock out plus 0.11 equals cost of a stock out. I'm going to go ahead and grab that 0.95 and bring it over here, and then divide by 1 minus the 0.95. You grade 0.95 times the 0.11 stays here. The 0.95 times the cost of the stock out goes over here. That becomes 1 minus the 0.95, and I divide it, right? So somebody count it out. $2.09. Or if you will, 209%. This is the hardest thing to get people to understand. because we're so used to working in one direction. We're so used to getting the numbers and it tells us what the Q should be. We're so used to getting the numbers and it tells us what R should be. That what we think we're doing when we do this is we're saying, oh, by setting the service level to 95%, we believe that the cost of a stock out is 209%. So every $1 of stock out that I have ultimately cost me $2.09. That's what we're believing. Now, one second. That is not true. Here's the way I want you to think about it. The way you're testing service level when you do this right here is you're saying, is it reasonable to believe that's true? Do I believe that for every $1 of stock out I have, ultimately it's going to cost me $2.09? If I do, then that's a reasonable stock out. But if I don't, then that's not a reasonable stock out. Another way to think about it is 11% versus 209%. We're basically saying a stock out is about 20 times worse than holding unnecessary inventory. Again, can I tell you what the right answer is? I cannot. I can only give you that gut feeling. So one sec, Frank, let me do my finale and then I'll ask you a question. Here's what I would tell to Bill. I'd say, Bill, I've taken your information. I've gone through and I've established, based on the information you've given me, the appropriate continuous review policy. Q should be about 11,600 plates. You should order when you get down to about 12,185 plates. We're talking about 768 plates, not 716. We're talking about 768 plates of average inventory. And your total average annual inventory cost that you got tied up in this stuff is going to cost you about $170,000 a year. Now, if you don't like those numbers, we've got to go and attack the Q because it's the biggest thing. If not the Q, then we can attack the service level. If we attack the Q, we got to do something that makes that number lower. And we could take a lesson from Toyota. We'd end up having to drive our setup cost much lower than they currently are. And or we would have to understand that actually our inventory is a lot more expensive than we thought. But if we can't do that, we're stuck with this Q. We can't arbitrarily change the Q. So then, the only other thing we have to play with is the safety stock. The safety stock is governed by your service level of 95%. What that is currently doing to us in this case is that service level of 95% is causing us to expect the stock out a bit less than every 3 years. Does that sound right to you or not? Let's test our feeling about that. Oh, by the way, for that 95% service level to make sense, you have to believe that every time you have a temporary stock out for, whatever the dollar amount is of the stock outs, that the ultimate cost to you for every dollar of stock out is actually almost 2.1 times that. Do you believe that to be true? If you believe that to be true, and you think it's appropriate to leave it at 2.75-ish years, then you're going to have to be satisfied with $166,000 in inventory following this policy. That's what you say. And any answer other than that is just wishful thinking. Frank, you had your hand up.
Weird.
What does the CSS stand for? How did you know it was 11%? Because the 11% is wrote down as very
trying
Yeah, it's the safety stock. It's the cost of the stock. I mean, the cost of the safety stock. It's the whole thing. That's why these are in rates, okay? So I used a rate, 11% there, and I found out a rate here. If I don't want to use rates, I can do something else. So for your homework, try this. Let's talk about it a bit on Wednesday. All you are responsible on the final exam for is being able to solve a QR policy, establish those numbers like I told you up there, and be ready to have the discussion that we had. Okay, that's all I need from you. And I will post I will post a video that we have for this. Plus I will go and find a video from another class so that you can see that from its entirety, since I forgot to start the, yeah.
It's the final matches, homework 1, 2, 3.
I was taking videos.
What is the average annual total cost of the cycle stock, depending on how many I order at a time? So the cycle stock, guys, the cycle stock is in that picture. Do you see how if you backed up and zoomed far enough away? What you're going to have is a series of triangles. Now, sometimes the triangles get closer to the bottom, sometimes the triangles be further from the bottom, but you're going to have a series of triangles. Y'all see that? And you see how the height of those triangles is going to be Q? And do you see how, although the actual safety stock in any particular cycle will vary. Sometimes it will be bigger, sometimes it will be smaller, sometimes it will be zero. There's actually an average safety stock here. We can calculate the average. How close did it, on average, get to the bottom? So I want you to keep this picture in mind. We've got the up and down triangles, and on average, they get within the average safety stock at the bottom. That's what's happening. So on a right equation, and I'm not paying any attention to the safety stock right now, I'm just looking at the triangles. Why am I not looking at the safety stock right now? Because I control what safety stock is through the R that I pick. If I pick a big R, my safety stock is going to be high. If I pick a little r, my safety stock is going to be low. Do you agree? Pick a big ass R, my safety stock is going to be bigger. A smaller safety stock, smaller R, right? So that's a separate decision. That's the decision based on R. It doesn't depend on Q. It just depends on R. So all I'm looking at is these triangles right here. And I just want to write an equation for how much I'm going to have to pay on average on an annual basis if I order Q at a time. And you see up there, I tried to write it theoretically or conceptually, and then I put it in numbers. I'd like to know how much am I going to pay per year in ordering cost if I order Q at a time, plus how much am I going to pay per year for those triangles if I order Q at a time, plus how much am I going to pay per year for the items that I'm buying. Those are the three pieces to this. So let's write it as an equation, and then I'm going to do it as a spreadsheet just to show you this. Okay, let's start with ordering costs. So how would I figure out ordering costs? Well, let's let A equal average annual demand. So A is my average annual demand. We all agree with me on this? If I can figure out what my average annual demand is, and I divide by how many I order at a time, do you agree that that's how many orders on average I'm going to have per year? If I say on average I'm going to have 20,000, I'm going to order 20,000 units, and if I order 200 at a time, do you agree 20,000 divided by 200 is 100 orders per year? Whereas if I order 2,000 at a time, it's 20,000 divided by 2,000 is 10 orders per year. So A by Q is the number of orders per year times S, and we're over here, S is how much I'm going to pay per order. So there's my average annual ordering cost. A by Q is the number of orders per year times S, which is how much I paid for each order. And then the next term is, well, how much am I paying for these big triangles? I forgot who asked me. It might have been John. But what if I ordered 1 million at a time? Well, I'd have a gigantic triangle of 1 million and I'd be drowning in inventory. But if I ran it long enough, I'd just have big triangles of 1 million, wouldn't I? So take a look at this. I need to know how much average inventory I have and multiply it by the holding rate. So take a look at this picture. We don't care about safety stock, that's coming in later. We're just looking at the height of the triangles. Do you agree in a long run average, the average of a bunch of triangles is Q by 2? You have a whole bunch of triangles of height Q and you want to know what the long run average is, it's Q by 2, right? Okay, so don't we have Q by 2 average inventory? Long run average is Q by 2. Yes? Give me a more enthusiastic yes.
Yeah.
Yeah, Q. we don't say, what the hell do y'all say?
I don't like.
Okay, sorry, that's in your service. Okay, so that's the average inventory, but that's in units, correct? So now I have to turn it into dollars. I want to know how many dollars I have. Well, C is how much I pay for each of them, but C might be a function of Q by our picture up there. So this is average number of units times how much I paid for each unit, given that I ordered Q at a time, so this becomes a dollar amount. Then I multiply it by the holding rate, and that will be my average annual triangle costs. So we've got paying for the orders, and then we got the average annual triangle costs, and then how much did we actually pay for all of our items? Well, if we order A a year, and we pay C and Q for each of them, that's how much we paid for our items. So our objective is to look at that equation right there and pick the Q that gives us the lowest total cost. That's all we're doing. Pick the Q that takes the lowest, that gives us the lowest total cost. Now, in principle, those of you guys that like calculus, that sounds exactly like a calculus problem. Take the derivative with respect to Q, set it equal to 0, solve for that Q, and we will do that. But first of all, I just want you to see how easy this is, because y'all all know spreadsheets better than I do. So let's just pick a really simple example. All right, looks like we have some product we're trying to place on an inventory policy. Our average annual demand is 1,200 units, so that's A. We do get volume discounts. If I order between 1 and 5, I pay $150. If I order 6 to 9, I pay $150. Is the foundational periodic review policy. How does it work? Well, it's going to have exactly the same kind of drawing. This axis right here is time, and this axis right here is number of units in inventory. All right? Same exact thing. In fact, let's assume it's the same demand. So I'm going to be trying to draw the same demand patterns here, okay? There's nothing, you can have the same demand from your customer base, irrespective of whether you follow a QR policy or a TTI policy, right? Demand is demand. All right, so what's going to happen? Well, a TTI policy, you notice there's no Q and there's no R. There's a T and a TI. So what are those things? Well, it turns out T is going to be our base review period. So T is a time. Every 7 days, every 14 days, every 3 days, every day, every 47 days, whatever you want your T to be. This is the period at which you take action on your inventory. Remember, if something happens in between those periods, nothing happens until the next period. Clear? Okay, so let's just draw these. Let's draw, here's a T, and then here's another T, and there's another T, and so forth. Okay, these are the intervals, and we've just determined. You don't know how we got these yet. I'm gonna have to show you how to get them. But these are the periods at which we go and check stuff. All right, now what's TI? TI is equal to target inventory level. So this is going to be a target we're shooting for. Now this is going to generate a whole bunch of questions in just a minute. Check this out. The empty graph has those T intervals on the time axis, and the empty graph has that target inventory level on the y-axis. The empty graph over here only has the R. The Q's are the ones that show you how tall the triangles are going to be. So how does this one work? So I'm going to start this inventory. I'm going to try and keep it about the same thing that's here. So this is it, inventory, and it's going down. Now remember, in between these intervals right here, I may or may not know my inventory, but I'm taking no action. So my inventory is declining, hopefully at about the same rate as declining over there. What happens? The dinger has done, the clock has said it's time to go check my inventory. My system or me, I go and I physically count my inventory. So at that point in time, I establish how much inventory I have in my inventory. Got it? Then what do? I place an order, but I never said anything about Q, so there's no Q here. What order do I place? I simply place the difference between what I just counted and that target inventory level. That's what the TI is. It becomes the thing that tells me how much I'm ordering. So it's Monday morning at 8 a.m. and every Monday morning at 8 a.m. I go check how many bumper plates I have. I count how many I have, and I place an order at 8 a.m. on Monday morning with my supplier for the difference between what I have versus whatever this target inventory level is. Everybody agree? Now what happens? The exact same race starts now. So the exact same red lead time is going to occur, and the exact same red U is going to occur. And if I set this up right, pretty close to the same safety stock is going to occur. So let's draw this. So the red lead time race starts just like it did before. Okay, but don't I keep selling? So my inventory keeps on going down. It's going down. In this particular case, just like as in that case, I didn't run out of stock. My inventory arrived, right? My order arrived. How high does this get? It does not get all the way up here, does it? Because I placed an order for this much, but I sold stuff. So it's only going to get part way up. That doesn't matter, okay? It doesn't matter because that was only a number used to calculate what the Q is. I knew I was going to sell stuff. I never intended to get up to that. It's just a thing. It's unfortunately called the target inventory level because it makes it sound like you're actually trying to get all the way up there. If I had just called this capital letter A, and I said every time you come to a review period, you order the difference between capital letter A and whatever you have, you wouldn't get hung up on the fact that it didn't get all the way to capital letter A. But because it has the name target inventory level, you feel like you gotta get up there. Unnecessary. We're just gonna set that so that this system behaves the way we want it to behave. So what happens? Now it happens again. This time you place an order.
Does Q always equal just sales?
Q is going to be, we don't know what it is, okay? Q is going to be the difference between how much we have on hand versus whatever this number happens to be.
If you start at target inventory, doesn't it just
But
always?
remember, we never got up to target inventory. Target inventory level is a fake number. If I called that A, then we wouldn't have that number. So the answer is not good, okay? So let's try this. Remember how in the other example over here, I called this U bar or U? It's the exact same U here. Remember, I called this safety stock. It's the exact same safety stock. Now this time, when I start running this, what's going to happen? I'm going to run out. Assume that I had the same 95% service level. I had the same demand during this time. And basically what happened is, unfortunately, I ran out of stock before it arrived. And then it arrives and we continue on again, okay? All right, let's test these two. I want to test these. And then I want to show you, I want to tell you some things that might be surprising. All right. This, yeah, go ahead. No, go ahead.
Actually, you get to zero.
Not really, you don't. See, so we hit zero here, right? So what's going to happen? That means when we get up, we won't get up as high. So when we hit the next time, we won't be as low, which means we'll order more next time. So here, let me say this and then answer Coco's question. It turns out both of these policies are stable policies. They're not unstable. They don't get into trouble and do the circle of death. How does this account for variations in demand? You have periods of higher demand or periods of lower demand. How does this thing adjust? What happens?
And adjust with your demand.
Safety stock.
It adjusts in when you place the order. The height of the queue is always the same, right? But if it gets lower, it doesn't get as far above. If it gets higher, it gets further above. So this is self-adjusting. It adjusts in when it orders. During periods of higher demand, it will order more often. During periods of lower demand, it will order less often. Okay? This one at first can look unstable, like Randy was talking about. It looks like it can circle to zero. Turns out it's not. This is also a stable system. But it's not stable in when it orders because it always orders at the same period of time, right? It changes how much it orders. So the QI will get bigger during periods of higher demand and get lower during periods of lower demand. Both of them are stable. Go ahead, Jack, and then Arjit.
Target inventory could be like your warehouse space.
No, okay, so that's why
But you choose.
I wish they just hadn't called the stupid thing target inventory level.
Could you allocate for?
But we're never intending to get there. Understand, we're never gonna get to target inventory level because we're always gonna order the difference between this, and we're always gonna sell some shit while we're waiting. So we're never getting to target inventory level. But that's not a problem because we weren't trying to get to target inventory level. It was just a number we used to make a calculation. Yeah, I know, this is the thing I hate about this. Arjit and then Frank.
So I have a question regarding the variable cost. Now, since the quantity is changing, my per unit cost.
You're right, we'll get to that. I promise we'll get to what Arjit's talking about here. Let me just acknowledge that it's a good question. If I do, it doesn't mean the other ones weren't, okay? But hang on, it's just.
Sounds like
it's
it.
because- Hang on, it's just because I'm not addressing it right now, so I don't want you to think I'm blowing him off, okay? I can set Q to make sure I get volume discounts, can't I? All right? Over here, QI is varied. So sometimes I might have a bigger than necessary Q, so I'm gonna get my volume discounts. But sometimes I might have a smaller than the volume discount, and it might hurt me. So that's a disadvantage of this system, okay? Frank, you had a.
You mentioned earlier, so the time in which it reorders, that won't adjust?
This always orders at period interval T. It's always order
Always.
at interval T.
It's
Always
not something
order.
to where the first order, then you kind of look at, oh, how's the demand been doing, and then,
No.
hey, you know what, we're gonna
Can,
reschedule.
hang on. Can you create some kind of combination between these two? Sure you can.
Yeah.
But in its most pure form, the QR policy says, don't give a shit what you want. I'm gonna order when the system shows me that I hit my reorder point. In this system, it says, don't give a shit what you want. I'm gonna order at whatever that interval you said is, okay? That's the base system. Now, real systems, we're probably gonna do some modification, which I wanna talk about in just a second. But I want you to understand this first. So, in principle, a QR policy is better than a TTI policy in terms of the amount of inventory. Why? Okay, why? Let's think about this for a minute, okay? I want to introduce an idea called risk time or risk demand. I want you to stop and ask yourself this question. In a continuous review system, what is the period of time I'm at risk of running out of stock? How often do I know the information, and what is the period of time that I'm at risk? I hope you see that it's just the lead time in this example. Because if I'm way the hell up here, and I get a massive order, if that massive order takes me down to or below the R, I'm immediately gonna place my order, and then a lead time later, something's gonna come in. So the period of time I'm at risk in this is lead time. Agreed? The amount of safety stock I'm going to have is going to be dependent upon the risk period, which is just the lead time. I need enough safety stock to protect me against the risk during the lead. Do you agree? Now, I want you to come over here. It takes a minute to think about this, but think about this one. I need enough safety stock in this system to protect against my uncertainty in demand over the risk interval, which is just lead time. Maybe a way to do it is contrasting. Come over here. Let's do the reductio ad absurdum, the worst case outcome. So, my world is going fine. I get up to this interval period T. I count this inventory right here, and I place an order for QI. Do you agree? Yeah. Do you agree that order for QI contains within it all of the information that has happened prior to T?
Yeah.
Right? So the QI that's going to arrive over here later, right? This QI is ordered here, it arrives here. That QI is based on this QI, which is containing only this information. Now, 1 second after I place my order, 1 second after I place my order, I get a big order. When will I first know about that big order?
A week later.
A review period later, a T later, right? So a T later, I won't know. Don't get confused by this sucker. because this sucker is contained in that information, which did not contain the information